When you say that there's direct evidence that the universe has a beginning, what do you mean by that?
You're seeing Joe Rogan press former geophysicist Stephen Meyer on why the scientific evidence seems to support that the universe had a beginning and doesn't just stretch infinitely into the past. Specifically, Rogan is going to press the scientist on two things. One, whether modern evidence has disproven the beginning of the universe in something like a Big Bang, and two, why the beginning of the universe seems to support the notion that God exists. What Meyer says in response amounts to what some people think is actual proof that God exists. But in this video specifically, you're going to see ridiculously strong reason to believe that the universe began to exist in something like the Big Bang and doesn't stretch infinitely into the past. We need to hear the setup conversation first, but then we'll hear the clip that I think will blow your mind. But let's jump in as Rogan presses him on the scientific evidence.
So back to the ancient Greeks, we've had this debate. Is the universe eternal and self-existent? Has it always been here? Or is it finite? Did it come into existence at a point in time? In which case, was there possibly an external creator that brought it into existence? In the 1920s, we get the first scientific evidence that helps us to answer that question. Coming into the 20th century, most physicists assume that the universe is eternal. It's infinite, it's past eternal. You can go back as far as you want. There's always matter, there's always energy, there's always space, there's always time. In the 1920s, Edwin Hubble is at Mount Wilson in Southern California, the big observatory there. He's a lawyer who's come into astronomy at a very propitious time because the astronomers have just started building these great dome telescopes. And they've also been developing photographic technology that allows them to collect a lot more light over a long period of time. And he starts looking at the distant galaxies that astronomers now think there's 2 trillion galaxies in the observable universe. It's just unbelievable how much our awareness of the vastness of the universe has expanded in really 100 years. It's amazing. Right. But the second thing that Hubble discovered is the light coming from those distant galaxies is being stretched out. If you shine light through a prism, it separates into the colors red to violet. And the red light, it corresponds to light with longer wavelengths. And what he's detecting is light that has shifted in these spectral analyses that they do in the red direction, suggesting that its wavelengths are longer, as you would expect if those galactic objects are receding away from us, if they're moving away. So it's like the Doppler effect with the train whistle. If the train's moving away, the pitch of the sound goes down. And that's because the sound waves are being stretched out. Well, the same thing happens with light. And so very early on, as he's studying the galaxies, he's realizing that there's not just a lot of them, and they're not just separate from our galaxy, but they're moving away from us. And in fact, the further out they are, the faster they're moving away. And so that gives rise to the idea of an expanding universe, because to explain that observation, you have to posit something like a roughly spherical expansion of the whole to account for that, what's called the Hubble relationship, that the further out, the faster they're going. And so that's big discovery number 2 for Hubble. First, there are other galaxies. Secondly, they're moving away from us, and that is suggesting that the universe as a whole is expanding. Now, as you wind that picture of the universe backwards in time, if in your mind's eye you think of, they call it back extrapolating, what the universe would have been like 100 years ago or 1,000 years ago or a million or a billion, however old the universe ends up being, eventually all that galactic material would have converged to a common point past which you cannot back extrapolate. So that point then marks the beginning of the expansion of the universe, but arguably the beginning of the universe itself. And so that's arguably. Now, there, I think, are other developments. Both
can I pause
go ahead.
right there?
Oh, yeah, that's, again, another long explanation.
But that's okay.
Yeah.
So we're talking about 1920, right? Now, imagine the detection ability that we might have 500 years from now. Maybe this information is not the big picture. Maybe there's a lot more to be discovered with advancement of science and astronomy as they can develop methods to look deeper and deeper into the galaxy. I mean, aren't we finding some things with the James Webb telescope that are leading some scientists to question the actual age of the universe itself?
I was going to talk about James Webb after you started the question, but it's the James Webb, I think, has provided. First of all, the answer,
there is some debate though now about the timeline.
Well, the debate, as I understand it, let me answer the first part of your question, and that is, of course, all the arguments that I make in the book are provisional based on the best science that we have. Right. And that's all we can do as scientists and philosophers of science, okay? We're not...
but we're looking at a very limited amount of data that we can acquire from things that are 13.9 billion light years away, right?
Sure, but it is striking how decisive the indicators are of a beginning based on what we're discovering. And James Webb has only reinforced that.
Now, here's the first of two big moments. Has modern science shot down the Big Bang beginning to the universe? Meyer's going to explain the shocking and controversial reasons some people seem to think so. And then after that, we're going to get to that big moment, that clip that I think is going to blow your mind and what it means about the existence of God.
Yeah, there's been a lot of media reports suggesting that the findings of the James Webb Telescope have undermined the case for the Big Bang or the Big Bang theory. But there's an interesting backstory on this. Most of these media reports were based on the writings of a single physics researcher named Eric Lerner, who's been, since 1990, kind of carrying a torch to refute the Big Bang. And Lerner, in one of his articles, quoted a University of Kansas astrophysicist saying that she stays up late at night wondering if, based on the James Webb, that everything that we know is turning out to be false. Turns out that researcher, that astrophysicist, disclaimed his use of the quote, explained that he took it completely out of context, that she was talking about theories of galaxy formation, not about whether or not there had been a Big Bang, and not about whether or not the universe is expanding as we would expect.
So he's confirmation bias.
Yeah, and in a sense also taking somebody way out of context to make a point of his own. You know, he misused the quotation
on purpose,
apparently. So here's and there have been a number of leading astrophysicists. In fact, people who would like to know more about this, I'd recommend what Brian Keating from University of California, San Diego, great astrophysicist, has been writing about this. But here's the short story. I wrote an op-ed in the Daily Wired distilling some of this stuff. What the James Webb Telescope is able to do is to, in fact, what it was constructed to do was to detect extremely long wavelength radiation, stuff that's outside the visible range. I call it uber redshifted. It's actually in the infrared range is the more accurate physics term. So it's looking for very long wavelength radiation coming from galaxies that are very, very far out there. Now, why would it be looking for that? Well, because if the universe is expanding as we would expect based on the Big Bang theory, then the radiation coming from things very, very far out in space and therefore very far back in time should be very stretched out, more stretched out than stuff that's closer at hand. So the James Webb was constructed in hopes of detecting that type of radiation if it existed. It's not assuming that it necessarily would, but it would be a way of confirming the expansion of the universe has been going on for a very long time. And what they were in fact able to detect from these very ancient, very distant galaxies was super redshifted radiation, uber redshifted stuff out in the infrared. And we're able, on the basis of that, to synthesize images of these very, very distant remote galaxies. Now, the very fact that they were able to do that confirms that you have what you would expect on the basis of the Big Bang theory, that the amount of red shift that you would expect to be present if, in fact, the galaxies had been expanding throughout that vast stretch of time was, in fact, present and was detected. Now, that didn't get reported. The whole focus was on the fact that there were galaxies that were more mature, there were more of them early on than we would have expected based on our theories of galaxy formation. The basic picture of an expanding universe outward from a beginning has not been undermined, but rather confirmed in a very dramatic way at very great distance and for galaxies that are a very far look-back time, way, way back in time. So I think it's a rather dramatic confirmation. There have been many others. The cosmic background radiation that was discovered in 1965, the COBE radiation that George Smoot discovered in the 90s. So there's been this pattern of confirming evidence of this basic picture of an expanding universe out from the beginning in observational astronomy from the 20s right up till now. And so that, I think, gives us good reason to think best we can tell the universe had a beginning.
But is it possible that with further detection, we can, with new data, have a better understanding of what is actually going on rather than just saying it all points to this thing? Because it seems like there's data, but it's what you're describing seems like it's possible, at least in the future, to have better detection methods.
Yeah.
So the Big Bang stands, but now Rogan wants to press that age-old question. One day, what if science disproves that the universe had a beginning? We'll hear Meyer's answer, and then we'll move on to the second big moment where we talk about what this all means for the existence of God.
It's always possible that we can change our minds on things because science is always provisional, but there are many stable theories that have persisted because of a preponderance of evidence that points to and continues to point to the same conclusion. And I think we've had 100 years now where we've had repeated new types of observations that point towards a beginning.
Now, as we go into that big moment about God's existence, it's important to remember one thing. While the science seems to support the notion that the universe began to exist, you can actually do a fun experiment in your head sitting right where you are. If the universe had no beginning, then it means that time just stretches infinitely into the past. Now, infinity's a problem. It's not just a really big number. What's infinity plus 5? It's infinity. What's infinity minus 2 trillion? It's infinity. In fact, if you remove half of infinity, you still have infinity. Some people have thought of this like an infinite library with every other book is red and every other book is black. Well, what if you removed all the red books so that all that remain are the black books? Now, how many books do you have? Well, if you had infinity and you remove all the red books, you still have infinity. They're just now all black books. This means that if the point in time of this date on the calendar where we are right now is a point on a timeline, and the universe stretches infinitely into the past, then it means that no matter how much time passed, there would still be infinite to go. You would make no progress in arriving at the moment we're experiencing right now. As philosopher J.P. Moreland put it, it's like trying to jump out of a hole that doesn't have a bottom to it. No, the universe can't be infinite into the past. But with all of this in mind, let's move on now to that final big moment and find out what all of this means for God.
I'm a classical theist, and I think the scientific evidence is pointing in that direction fairly strongly, in part because we now have evidence from multiple lines of evidence suggesting that the universe did in fact have a beginning. The material universe does not look to have been eternal and self-existent. And so then to answer your second question, I would say that every philosophical system, sometimes philosophers talk about worldviews, whether they're formal philosophical systems or just sort of the informal set of assumptions that we all need to make about reality. But every worldview needs to answer the question, what is the thing or the process or the entity from which everything else came? What's the ground of being, the starting point? And up until the 20th century, I think the materialist naturalist view was very credible because it affirmed that matter and energy were eternal and self-existent in the same way that theists thought God was eternal and self-existent. But in both systems, or in all systems, something is what philosophers call the primitive, the thing from which everything else comes. I think as a consequence, or in the wake of our modern cosmological, astrophysical discoveries that the material universe itself had a beginning, that matter and energy is now a poor candidate to be that eternal self-existent thing. And therefore, I think that the theistic view that a transcendent creator is the thing from which everything else came, without itself being created, is the best place to start our philosophical thinking. It provides the best explanation for what we see.